Today we're going to integrate using substitution. So the substitution method is to undo chain rule and also to help us with product rule and to undo quotient rule as well. So the basic idea is that we're going to substitute out, if I have um, a function that has a composition, what we're going to do is substitute out the inside part of the composition. So in this case, it would be g of x. And we, so what happens is when we substitute it out, it's going to cancel out our g prime of x. And then what we end up with is just taking the antiderivative of something simpler, something that we can use like the power rule to take the antiderivative of. So it's always to make, what we're doing is substituting out part of the expression so that we can take the antiderivative a lot easier. Okay, so what we're going to do first is let u equal an expression whose derivative will cancel out some other factor, okay? And then we're going to do a bunch of steps. So we're going to follow these steps basically. Here we go. So right now, I could expand out x squared plus 1 to the 4th power and then multiply it by 2x and then undo, so take the antiderivative using basically reverse power rule. But because that's going to take a long time, we're going to try something else. We're going to try U-substitution. So I noticed that if I take the derivative of x squared plus 1, it's going to equal, so I'm going to say u is equal to x squared plus 1. And if I replace the x squared with 1 with u to the 4th power, that would be a lot easier than expanding out and taking the antiderivative. So what you have to do when you replace something with u is you have to take the derivative of u. So du is equal to 2x. So the derivative of x squared is 2x. The derivative of 1 is 0. And times dx. So basically the change in u is equal to the derivative times the change in x. Okay, so we then have to replace out dx. So I need to solve for dx. I will divide by 2x. So dx is equal to du over 2x. So I'm going to replace dx with du. So we'll be taking the antiderivative with respect to u instead of with respect to x. So notice when I did that, my 2x and my 2x canceled. So I end up with, now I'm taking the antiderivative of u to the 4th power du. And I can totally take the antiderivative of u to the 4th power. We raise the power by 1 and then divide by that power. And of course, since it's an indefinite integral, I need to add the c value. The last thing that we would do is substitute out the u with our original expression for u so that our equation is still written in terms of x. So I get 1/5 times x squared minus 1 to the 5th power plus 1, sorry, plus c. And that is that. Number 2. So we have, remember we're looking for the inside function. We're going to take the derivative of the inside function so that it will cancel out my little tacked on term. So it looks like if I take the derivative of x cubed plus 1, it's going to cancel out some part of x squared. So let's make u equal to x cubed plus 1. So I have du is equal to 3x squared dx. Solve for dx. I get du over 3x squared. All right, so I like that. I'm going to go ahead and rewrite this. My 3x squared stays, and then I'm taking the square root of u du over 3x squared. My 3x squareds cancel. I'm going to go ahead and rewrite my square root of u to the 1/2 power du. Now that is something we can take the antiderivative of. So u to the 3/2, we raise the power by 1, divide by 3/2, or in this case, I like to multiply by the reciprocal. Adding on our c, since this is an indefinite integral. And then we replace back the u. So 2/3 times x cubed plus 1 raised to the power of 3/2 plus c. These are fun. I like these. All right. So we undid chain rule. Okay, this one, I see secants and tangents, and I just remind myself that, so the derivative of secant is secant tangent. The derivative of tangent is secant squared. So since the derivative of tangent is secant squared, I'm going to make the u equal to tangent. Tangent x, so du is equal to secant squared x times dx. Divide. So basically the derivative goes into the denominator of du. So dx is equal to du over secant squared x. All right, let's rewrite. So I have secant squared x, and then my tangent is my new u, so times u. And we replace dx with du over secant squared x. Again, ta -ta -ta. We're going to cancel out the tacked on term. So we get u, the antiderivative of u du is u squared divided by 2, so times 1/2 plus c. I like fractions better than dividing, so I always use a fraction, or I like to use a fraction. And then our last step is to take the u and replace it with our equation in terms of x. So tangent squared x plus c. All right. Number 4. And then we'll have a few more to do on the back. Okay, so this time I usually look to see what kind of, what is on the inside function. So the inside function is 5x. So because if I replace the 5x with a u, I can take the cosine of just like a plain variable, but the cosine of 5x, I don't really know how to take the antiderivative of that. Okay, so start there. I'm going to start with u is equal to 5x. So I get du is equal to 5 dx, because I'm taking the derivative. Divide by 5. So we get dx is equal to du over 5. So dx is replaced with du over 5. Again, the 5's cancel. Yes. So now we're just taking the antiderivative of cosine u du. The antiderivative of cosine u, so antiderivative would be sine. So the sine of u plus c, replace u with 5x plus c. All right, and then we'll go on to number 5. 3 more. Okay, so this time we have a lot of nested things here. So what looks like the inside function, it's not always super straightforward, but I think that I want to replace this x squared plus 1 with a u. Okay, the worst thing that happens when you use U-substitution is that you replace something out and it doesn't work. Like your equation does not get simplified enough, and then you have to figure out what else you could replace as u. Okay, so we have du is equal to, the derivative of x squared is 2x. Derivative of 1 is 0, so times dx times the change in x. Solve for dx. So dx is equal to du over 2x. All right, let's replace. So I only replace my x squared plus 1 with u, so that would become u squared. And then the dx replaces with du over 2x. My x's cancel. And since I have du over 2, that's basically like 1/2. So I'm going to pull it to the front since it's a scalar. So 1/2 times u squared du. Next up is to take the antiderivative. So 1/2, and then we're going to take the antiderivative of u squared, which is u cubed times 1/3 plus c. So I get 1/6 times u is equal to x squared plus 1 raised to the 3rd power plus c. Okay. So reverse chain rule here. All right, next up is, what is our inside function? It looks like our inside function is going to be x cubed plus 2. So we're going to do u is equal to x cubed plus 2. Du is equal to 3x squared plus 0, so dx. Dx is equal to du over 3x squared. All right, let's replace and see if we can take the antiderivative once we do that. We get 2x squared times u to the 1/2 power, since it's a square root, times du over 3x squared. Let's see what cancels. Oh, x squared, yes. Okay, we're hoping to get just u's in the end and like a pretty simple looking expression. All right, so I get 2/3 on the outside, and then the integral of u to the 1/2 du. So I have 2/3 times u to the 3/2 times 2/3, since we're multiplying by the reciprocal, plus c. So simplify, we get 4/9 times x cubed plus 2 raised to the 3/2 plus c. All right, let's try one more. Number 7. Okay, again, I see secants and tangents, so I remember that we have to take the derivative of something, and the secant squared is like on the outside of the parentheses, so I'm thinking that that's what I'm going to cancel out. So luckily the inside is u is equal to tangent x plus 3, so the derivative of tangent would be secant squared x. The derivative of 3 is 0, and then times dx. So dx is equal to du over secant squared x. All right, so 2 secant squared x times the inside, which is u to the 1st power. Dx is replaced with du over secant squared x. Fun. Okay, so those cancel. Love that. So I get 2 times u du. All right, so I have u, the antiderivative, let's see, 2 on the outside, and then the antiderivative of u to the 1st power would be u squared times 1/2 plus c. So my 1/2 and my 2 cancel, and u was tangent x plus 3, so I'm going to write tangent x plus 3 squared plus c. Okay, and that's it. Make sure I put my c there. Okay, that's it for this one.